My name is Andy Cotgreave, and I'm here to talk to you today about something we've been doing with our Tableau research team, something I've been working on for the last year that's been really exciting. My name's Andy Cotgreave. I'm technical evangelist at Tableau. It's 10 years ago this week that I downloaded Tableau as a customer, and that was a moment that kind of changed my career. This year, I released the big book of dashboards, 28 real-world case studies about dashboards that you can steal from like an artist in your own business. So if you're building dashboards or responsible for looking at dashboards, be delighted if you checked it out. This talk isn't about Tableau specifically. I'm going to be talking about one thing we're doing in the research team. But if you've not checked Tableau out in the last couple of years, we are here on stand 557. We're out there, this side of the AI theater. We've completely transformed the platform in the last couple of years. We've gone from being just a visual analytics product to an enterprise data platform. So we've got products and solutions that are out in the field now and on their way that are covering everything from data storage to data preparation and improved visual analytics. I want to start today by looking at a picture. And we've got a nice aisle here, so I'm going to divide you in left and right. So over here, I want you to look at this picture that I'm going to show in a moment and consider how old are the people in the picture. And on the right-hand side, your job is to memorize what they're wearing. Okay, so you're going to, how old are they? You guys, what are they wearing? And we'll spend about 10 seconds looking at this. Oh, silence. It's so nice, a bit of silence. Brilliant. Right. Now, because this is a session about eye tracking, you are probably slightly self-conscious about how you looked at this picture. This is a very famous bit of research done by Alfred Yarbus in 1967. He used this painting, Unexpected Visitors, by Ilya Repin, to look at how people look at the world around them when given specific tasks. So over here, you will have looked at the bodies of these people, trying to get that clothing into the memory. Over here, you will have looked at their heads. And you all will have had similar patterns to those. So what has this got to do with Tableau? Well, at Tableau, we spend 26% of our income on R&D. We've got an industrial-class research team focused solely on the mission to help people see and understand their data. Headed by Jock McKinley. He's one of the godfathers of information visualization, but we also have experts in machine learning, fast database technology, the use of color in design, and much, much more. What we do in our research is try and focus on the big things, like faster, better data storage, but also the small things, the things that make your experience with data much more important. So when we ask, well, should we do eye tracking in Tableau? The answer is very, very simple. Our mission is to help people see and understand data. Now, as our platform grows and we see people with bigger data sets, bigger data storage, using our data storage, they then need to prepare that data using our tools or third-party tools. They then need to analyze that data, create insight. But importantly, however big the platform gets at the top, you still need to communicate that insight so that it becomes actionable for the people consuming the data. And we do eye tracking because we want to be able to mainline the insight into your brains quicker so that you can answer questions and get on with making decisions as fast as humanly possible. My own interest in eye tracking comes from this research, which was done at the turn of the 20th century by Don Norman and Jacob Nielsen. This is very famous in the world of design, and they used eye tracking to look at how people looked at Google search results and text-based news pages. And they discovered what became known as the Fpattern, which kind of superseded a traditional Z pattern which had been observed on print pages. Essentially, with the Fpattern, people concentrate visual attention in the top left. They go most of the way across. They come down a bit. They go less far across, and then they get bored and just go to the bottom of the screen. I've been teaching people how to use dashboards for the best part of 6 years and how to build them. And my mantra was always, well, that was how people looked at screens. So this is what you should do when you build dashboards, of course. At which point, my colleague Amy Alberts comes on the scene. She's been with the research team for a couple of years and has been using eye trackers in her user research for over 15 years. And we were having a conversation one day, and I was talking about the Fpattern, and she went, well, do you have any data to support that hypothesis? At which point, I had to admit, no, I didn't have any data to support that hypothesis. I had just assumed that because the Fpattern existed for Google pages, that is also how we should lay out dashboards. And making assumptions based on previous research and applying those to data dashboards would surely be a spurious thing. So here we are 18 months later with some of the outcomes of this research. And what I hope today is to give you some ideas of what we've discovered. What I've discovered about research is that you never get a definitive answer. We get ideas, and what we've actually got is more questions than we have answers, but what we've got is really exciting to show. So the first thing we did, we said, well, how much existing research is there with eye trackers and data visualization? And there is nothing on dashboards. There is a body of research on memorability of individual charts, such as this paper from Michelle Borkin from Canada. But she's just looking at individual charts. There's a whole bunch of eye tracking research in academia based on advertising and various other aspects of things we look at, but nothing about dashboards, which is what an audience like this is interested in. So we set out to change it. Now, how do we do eye tracking? This is taken from Yarbus's book in 1967. He apparently seems to take great glee in taking 3 pages of how to actually describe putting the sellotape on the eyelid and then pulling it backwards and determining whether it should be this way, that way, or the other. In fact, his entire book from 1967 reads like something of a torture manual. What you would have to do is put your head on this metal apparatus, then close your mouth around a bite plate to lock your head in place. Then rods would further lock you in place by going into the side of your temples, at which point they would tape open your eye, then put a plexiglass mask on your face, and finally stick a rubber suction cup onto your eye. Does anybody want to do some eye tracking research with Tableau? No, maybe not. Well, I'll show you how we do it now. He also describes that using this apparatus, it's probably best just to do experiments that last 5 minutes long, but maybe you can do 10 to 12 minutes without doing any damage to your participants' eyes. So, pretty sketchy stuff. This is how we do it in 2017. The eye tracking technology is commodity hardware. You can buy Tobii trackers like the ones we use for about £100, and you just attach them to the bottom of your monitor. So it's quite easy to do a study with us. What we're trying to do when we look at the eye is use the reflection of light on your cornea to see what has happened, to see where your fovea is pointing. So the fovea is a cool part of your eye's anatomy. As you consider your entire field of vision, everything you can see in this moment, the fovea is just 1/10,000th of the field of vision. So it's a tiny part of what you can see, and yet on the retina, it controls 50% of the nerves in the retina. So it's a tiny part of your field of vision, but it's a complete resource hog. And what we do when we eye track, in our case, is show people dashboards, and then we can see exactly where they're looking. So here's Victor looking at a dashboard from the Financial Times, and we know where he is looking. From that, we do studies with between 100 and 150 people, and we can aggregate the data to discover where people look at dashboards. And the results have been absolutely fascinating. I'm going to show a couple of ways in which we measure the data visually, and then talk about a little bit more later on. The most well-known is the heat map. The hotter the temperature, the hotter the data, that's where most visual concentration is concentrated. So you can see in this one, there's a very strong Fpattern. But the problem with heat maps is they obscure the things that are most interesting. So what we use at Tableau mostly is what's called a gaze opacity map. And that is like scrubbing a window clean so you can see which bits most people look at most often. So that's one of the outputs. And the kind of data we're collecting are based primarily around two different measures. The first one is time to first fixation. This is when you define a region, such as the person on the dashboard, how long did it take for them to first look at that dashboard, that region on the dashboard? And then the second one is fixation duration. Define another region on a dashboard or on a screen and aggregate how long people spend in that part of the screen. From that, we can begin to infer where people are looking for how long and start to make conclusions. Now, I'm sure you're all behaving like researchers and thinking, well, what about X? What about Y? What if this? What if that? And believe me, we have thought of all those questions too. There are some limitations. First of all, with eye tracking, we are just tracking where they look. We have no idea if this man looking at that dashboard actually understood anything, but we know where he looked. Secondly, in the first two studies, we asked people to do a slightly artificial task. We said, just look at this dashboard that you've never seen before for 10 seconds. We gave them no guidance or particular direction to look at. Now, your CEO might phone up one day and say, I need a dashboard tomorrow just before I go into a board meeting. It had better be good. He or she puts the phone down. You've got to design something that is going to catch their eye in an instant. But we know most dashboards are things we use maybe week in, week out, and we're slightly familiar. The reason we started here is because we need a baseline. We need to know what unguided attention is, and as we continue the research over the coming years and months and years, we will, as you'll see, we're doing more guided results and activity then. So we've done 3 studies. I'm going to share details of the first 2 and give you a little reveal of the most recent one, study 3. In study 1, we wanted to focus on 4 hypotheses. First of all, was Andy wrong? Does the F pattern exist in dashboards? Is it something we see in dashboards? Hypothesis 2, are jaggedy lines that maybe imply movement and animation attractive to people looking at a dashboard? Study 3, little call-outs. When we put red or arrows on dashboards to indicate something that needs attention, do people look at those? And study 4, what about iconography? Does the familiarity of a phone draw people's eyes? So we ran this study at a Tableau conference in Austin in 2016. We created a lab space, and 150 people ran through this study. And the first thing we asked, or Amy wanted to know, was I wrong? She's quite a competitive researcher. Does it turn out that the F pattern is not necessary? So just to recap what the F pattern is, it's concentrated attention in the top left, and then waning attention from as you go across and to the right. And you can kind of see it on this, but if you look at this down here, that's not reflective of the F pattern. For some reason, this area chart is a real attention grabber on this dashboard. Now, we don't quite know why this one works, but while we're seeing an F pattern in lots of dashboards, we're not seeing it in every dashboard. And in fact, in some dashboards, we don't see it at all. So the Financial Times dashboard we looked at a moment ago, this one was more like a jellyfish. People start at the top and then sprinkle their way down, like a jellyfish or a cloud of rain. And in hindsight, what we've concluded seems really obvious. There is nothing in the top left or top right of this dashboard. But what we think is going on is that our brains are incredibly powerful. We should not be beholden to the F pattern when we look at digital screens. It is possible as a designer to direct people's attention where you want them to look. So was I wrong? I don't know. I still think the F pattern is a good starting point, but maybe it's not the only way you should approach building dashboards. Not all the results were conclusive, or not all our hypotheses were proven. We didn't see particular attention to particular types of chart, sort of rising lines. In that dashboard were not particularly attractive. Who knows, maybe because of other things going on in that dashboard. And also the phone icon, nobody looked at it. So in those cases, we didn't see our hypotheses confirmed. But one thing we did see, which we hadn't expected, was the power of what we call big-ass numbers, bands, or just big numbers. On this dashboard, there's a stripe of 5 numbers at the top, which were real attention grabbers. But we didn't see this in every single dashboard. In this dashboard, the numbers were smaller, and as you can see, they didn't grab much attention. I'll talk more about this one in a moment. So after study 1, we sort of started going down this path. We think the Fpattern isn't something we should absolutely religiously stick to as if nothing else will work. You can break the Fpattern on dashboards. And secondly, what we hadn't expected was the power of big numbers on your dashboards, which led to study 2 here in London at the Gartner Summit back in February. And we wanted to focus on the power of big numbers because this was the most surprising outcome of the first study. So we thought, all things being equal, what if we changed certain aspects of big numbers on your dashboards? First test, what if we moved them from the top to the bottom? Second one, what if we moved them from the left to the right? This is a website analytics dashboard where the original one, the bands are on the left and we moved them to the right. And third, our dashboard with the small numbers, what if we made them bigger? If we made them a little bit bigger, would that actually draw more attention to those figures? So, top or bottom, left or right, medium or large. Before I show you the results, let me remind you the 2 metrics we have. First of all, time to first fixation is how long did it take them to look at this region? And fixation duration is when they looked at it, for how long did they look at that particular region? So here are the results. In study 1, the bands were at the top, and in study 2, the bands were at the bottom. Now you can see from this that when we put the bands at the bottom, people didn't look at them. So that's quite a striking conclusion there, but this kind of thing needs to be backed up with data. You know, we're a data company, and making conclusions based just on opacity heat maps would be a foolish, futile thing to do. So we have data to back these things up. The bands at the top, people got to them in 1.9 seconds on average. The bands at the bottom, it took them over 6 seconds to go and see those numbers. And once they were there, they spent different amounts of time. When they were at the top, they commanded, on average, 1.5 seconds worth of the 10 seconds of attention, and at the bottom, just over half a second. So it appeared in this dashboard, all other things being equal, the bands at the top were a really powerful attention grabber. Now let's look at left and right. You can see visually that it looks like things are about equal. It did take people a little bit longer to get to the numbers on the right than it did to get to them on the left. But once they were there, they spent around about the same amount of time on each side. Not very much time on this dashboard, but again, all things being equal, left and right didn't seem to make that much difference in terms of visual attention. And finally, our small numbers compared to our big numbers. So the first thing you can see is that the big numbers grab much more attention in this one than in the study 1. But what you will all have done is looked at this person, because we have observed that if you put something that could be a naked person anywhere on a dashboard, people's eyes will be drawn to that. Now, I don't recommend that as a dashboarding data visual tactic. In this case, this is a dashboard about where people injure themselves and when they make insurance claims. So they had the legitimacy to do that. But you can see the bigger numbers made a big difference. At the bottom, at the big numbers, people took a lot less time to get to those big numbers, whereas when they were smaller, it took them longer to get there. And they fixated on the bigger numbers for longer. So that was study 2. Now we were beginning to get somewhere. We concluded that top or bottom really seems to make a big difference, and that fits to our understanding of how people look at screens and look at the world around them. Left and right didn't seem to make too big a difference, but the size did. Now, we don't have specific details of the thresholds or what other things on a dashboard might distract you. We'll keep on working on that. But that's kind of the summary of those first 2 studies. However, so to summarize there, we think the Fpattern is important, but not the only way to design a dashboard. Form is important. What are you actually trying to communicate? And then secondly, the thing that I really got out of this was the bands. The big numbers are really powerful. And over the period of writing a book in the last 2 years, this was something that sort of came to a big realization as we were writing the book, but also backed up by this study. It seems obvious, but a big number is the fastest way to communicate a key performance indicator. And what I see bands as being really powerful for is the headline. If you consider a dashboard or an analysis as a data-driven story, the bands are a headline, and you can look at that headline band and see, is that a number I need to take action on? And if it is, then you can go and look at the rest of the charts on the dashboard to get the detailed information you need to get the right amounts of insight. So we love bands. I think they've totally influenced my dashboard design, and it's great seeing them out in the field. So that's study 1 and study 2, and as I said, they had limitations. I'm sure you've all probably thinking of some limitations of these studies. One of the biggest ones was that this is unguided analysis. Here's a dashboard, look at it for 10 seconds, and enjoy the experience. So in study 3, which we did last month in Las Vegas at our Tableau conference, we wanted to begin examining what happens if we give people specific tasks. And so if you remember at the start of this, we had a look at the Alfred Yarbus eye tracking, where Yarbus had given people different tasks when they looked at the same picture. We wanted to see the different tasks change how people look at dashboards. So we're going to ask another question again, and I'm going to show you a dashboard about Makeover Monday. Makeover Monday is a project being run by Eva Murray and Andy Kriebel, 2 Tableau customers, where each week they share a data set, and hundreds of people each week. Last week they had 250 people taking their own time to remake the data, explore the data, and learn better data visualization skills. It's a great project. I recommend everybody gets involved. So I'm going to show you a dashboard about Makeover Monday participation. On the left, your question is how many people participated in Makeover Monday. On the right, particularly at the back, your question is going to be harder to answer, but how many times did Pooja participate? Pooja Gandhi is another superstar Tableau customer. She's participated a lot, but you've got to work out how many times she participated. Here we go. At the back, you probably can't read the screen, but you've probably at least worked out where the answer might lie. Right, now you're all experts in eye tracking. You might have been a bit self-conscious about how your eye was processing that information. What we did in the study in Las Vegas was show people one of 3 conditions. The first condition, not shown here, was the same as the previous studies. Just look at this dashboard for 10 seconds. So we could get a control, and we repeated the same observations from previous studies. But then we divided each dashboard into 2 conditions. An easy one, just look at the big number at the top. And for you guys, the harder one, the information is down at the bottom in the little chart down there. And what we found, we haven't done full analysis here. I'm just showing you 2 examples of two individuals, how they looked at this dashboard. And what we found is really interesting. We're beginning to recreate the Yarbus study with dashboards. Everyone over here, the easy question was very easy to answer. You very quickly probably went to the top and saw the answer was 11. But what's really interesting is it seems that the answer over here was just as easy. You can fly your eye over the big numbers almost instantly and then realize that's not where the information is and hone in on it almost as quickly. Now, we're still crunching the numbers, but what we think we're seeing here is this incredible aspect of human cognition and human psychology and processing about the fight between bottom-down and top-down and bottom-up processing. You know, our brains and our eyes might be influenced by the environment in which it's looking at, but if we have focused thoughts, maybe we can actually override the environment and look for the information as quickly as we can. Now, as I said, we don't have conclusive answers to this yet. We've only just started crunching the numbers. We just got back really from the conference and have started opening the data. So I don't have definitive answers about how to define dashboards. This is going to keep on coming and keep on being developed over the next 2 years. But to summarize, to repeat from the top, why do we do eye tracking studies? Well, our mission is simple. It's to help people see and understand data. As we expand our platform, we are making massive investments in the big aspects of data, in the data platforms, in data preparation, and much, much more. And yet, all of that is no good if at the top of that pyramid, people like you don't know how to communicate data more effectively. So over time, what we're learning from here will help us advise people how to build better dashboards and even allow us to build features which will make the dashboard creation process smoother and more successful for you as dashboard authors to create things which are more efficiently communicated. So with that, that is the end of my presentation. Do come and speak to me about my book or about the eye tracking research we've been doing. We've also got a booth fully staffed with people who can tell you all the cool things that have happened about the Tableau platform in the last year and might be on their way soon. And with that, I'd just like to thank you all for coming to Big Data London and have a great day. Thank you very much.